previously we gave the kind of the limit definition of this net volume that's bounded by a surface and a region in the XY plane. And it was, I did my best to kind of illustrate what was going on, but let's be, honest. It's difficult to represent these, especially in three dimensions, what exactly this looks like. So that's why we can turn to technology like Maple to help us visualize what's going on. So let's go ahead and do that. So I have several plots lined up. Let's just go through one by one, and let's take a look at the first one. So there it is. Maple chose a nice color scheme here, very, very colorful. But you can see the curved surface, right? So our XY plane is essentially the base. You can see the curved surface where your Z values are pretty low here, and then they dramatically increase. And that's because of the exponential function that's in this surface. But what's really important is that we can see, and you can see Maple does a really nice job of shading that region, that solid that's bounded above by the curve and then bounded below by essentially what looks to be a rectangle, maybe. Yep. Some kind of rectangle. So the rectangle would be the base of this solid, and then the curved surface would be the top. And again, what we're going to learn how to do is how to calculate the volume of that kind of shaded region or solid there, right? So let's take a look at this one. Again, you can see the curved top of this region. You can see the base and the XY plane, and everything is shaded. Here we can actually see right through it, right? Let's take a look at this one. And this is a good one because it illustrates the fact that your surface might be, part of your surface might be above. So look, again, here's your Z-axis. You can see you have some a part of the surface that corresponds to the positive Z values, but then a part of it is below, right? So you can see the XY plane, that's that flat plane right there. And you can see where the surface just kind of cuts through that plane, and part of the solid is above the XY plane, part of the solid is below, and in this case, this is where we would definitely refer to it as a net volume, right? So part of it would have a positive volume, part of it would have a negative volume, and then the total would be this net, right? You can even generalize this a little bit more. Take a look at this one. This one is the volume between two surfaces, and we can tell that there are two surfaces because we can see the curved top and we can see the curved bottom, and you see Maple does a nice job of shading everything in between, right? And eventually, yeah, we'll be able to find the volume of these sorts of solids, right? Just a few more. This one has an interesting base. It's not a rectangle anymore. It's actually a triangle. So you can have non-rectangular bases, but it's the same concept. The triangle forms the base of the solid, and then again, there at the top, you can see the curved surface. And again, we're going to develop a technique for finding the volume of what is shaded right here. What is this one? I think this is another rectangular base. Let's see. Oh, yep, it is. Well, actually, it's very similar to that one. Is it the same? Let me see. Yeah, actually, it is exactly the same, just a different orientation there. What about this one? Oh, yes, this one has a circular base. So you can see that the base of this solid is circular. And again, you can see the top is this kind of, it looks like a nice dome. It looks like a dome. It looks like a design that would probably go into some fancy, sports arena. But there's your curved top. Now you have a circular base. And the question again is, what is the volume of what is shaded in between the two, right? And here's our last one. This one is not really, the base is definitely not a rectangle. The base is like this boundary here, I believe is y equals x squared. This one here is y equals the square root of x, and that forms the base. And you can see the top now is that curved surface, and again another volume. Like, what is the volume? So this video is just meant to give you a visualization of what it is we're going to be computing. And when we talk about volume and you know, bounded above by a surface and bounded below by either a rectangle, a triangle, or a circle, or some other non-rectangular region, these are the types of things that we're talking about. So I'm just going to do a reverse scroll and go back up, and you can just admire them one last time, because in the next video now we're going to start crunching numbers and figure out how to actually compute these things, right? And the wonderful thing is we have all the tools that we need in order to start the computation. We just have to see how these calculations relate to, like, let's say the area calculations that we are pretty accustomed to. So there you go. Hopefully that kind of gives you a mental image of what we're going to be working with. So it might make the numbers a little bit more real, a little bit more practical. And so without further ado, let's head on over to the next video and see how to start actually computing these double integrals. See you then.